this section, we're going to finish up our discussion of what ellipses look like, and specifically we're going to be finding the equations given some conditions this time. So a quick comment I wanted to add on this slide, you should already have this information copied, so you shouldn't have to write down these equations again, but I did want to point out that the online assignments seem to use a slightly different form for setting up the equations. Instead of always having the a term in the front, whether it's got an x or a y underneath it, they seem to always put x out front. And sometimes the number underneath x is bigger, which means it's stretching more to the left and the right, or the number underneath y is bigger, which means that it's stretching up and down more. So what they're doing is they're flipping where the a and the b values are, rather than flipping the x and the y squared terms. And so that's fine. Either way works, since you can change the order of addition. It doesn't mess up anything on the formulas. But we are going to use these, so I wanted to make sure to still have them in the notes. Again, you should have this information already as well, so don't feel the need to recopy it, but I wanted us to be able to refer back to it. And one specific comment we're going to use several times is whenever they give you 2 points, like let's say they give you 2 of the foci coordinates, then I hope you guys will recognize that the center is always going to be halfway between them. So what we're going to do a lot of times is we're going to find the 2 coordinates and then take the midpoint of them, whether it's the major axis endpoints, minor axis endpoints, or foci. So here's our first example. They want us to write in standard form the equation for an ellipse with foci at 0, -3, and 0, 3. So you can see that in this graph, it might help you to even draw the points somewhere just as a rough sketch. You have a coordinate that goes down 3 and a coordinate that goes up 3, and those are the locations of the foci. So I know that I have to have an ellipse that's stretching up and down more, because the foci go in the same direction as the major axis length. The other thing that they're giving me is that the distance across the short way, the minor axis length, is a length of 4. So that's what we have to work with at this point. So when we're labeling the center, like I said, this is always going to be halfway between the coordinates they give you. So since they've given us a coordinate of 0, -3 and a coordinate of 0, 3, the coordinate that's halfway between them is going to be 0, 0. So this one is centered at the origin. Next, they said the minor axis length is 4. Well, if you look back at the equations, the minor axis length is always 2 times b. So for our example, we can say that 2 times b equals 4, which means b equals 2. Now, the only other value that we're missing at this point is the value a. However, since they gave us the foci length, if you look at the distance from the center to the focus, that length was a length of 3, which means that c equals 3. Now, c isn't actually used anywhere in the equation for an ellipse, but it is useful down here for the Pythagorean relation. A squared equals b squared plus c squared. Now, we don't know a squared yet, but b squared, 2 times 2 is 4, and c squared, 3 times 3 is 9. So now I know that a squared equals 13. You could even go farther to say that a is equal to the square root of 13, but that's not going to be necessary, because if you're looking at the equations we have, the denominators of the fractions actually are a squared and b squared. So it's okay just to find the a squared or b squared value and not take the square root of it. So the final thing we're going to do for writing our equation, the online assignments, like I said, are always putting x first. So it's x minus 0, but instead of writing minus 0 squared, we're just going to write x squared, because having the minus in there doesn't affect anything. So x squared, and then there's the same thing happening to the y squared, since the k value is also a 0, and it's always set equal to 1. Now, what we're doing with the way we write this equation is stretching more up and down. So the bigger value, the a value, is going to go underneath the y value. Since it's stretching up and down more, the bigger number goes underneath y. The left and right stretch is not as much. So don't forget that we know that b equals 2, which means b squared equals 4. So that would be the way we wrote our equation. And honestly, if this is a paper and pencil test, I won't care if you flip and write y squared over 13 plus x squared over 4 equals 1. Either way is fine. There's just some inconsistency with how the textbook is writing their equations and with how the online assignments are putting their answers. So this describes an ellipse with a center at the origin, because it's not adding any numbers to x or y. It's stretching left to right 2, because that's the x value, and it's stretching up or down square root of 13. So here's a second similar example. This time it's not going to be centered at the origin, just to add a little bit more work that we need to do here. So again, I like to start off by kind of plotting where some of the coordinates that they're giving us are. So off to the side here, I'm just going to do a rough sketch. We have one major axis endpoint is going left 2 and down 1, and the other major axis endpoint is going right 8 and down 1. Now the major axis endpoint, that means the long way that the ellipse is being stretched. So I'm expecting it to be something like that. Specifically, since we know those two coordinates, -2, -1, and 8, -1, if we can find the midpoint of those two, then that'll be the h and the k value. So the point that is exactly halfway between those, the dot I just drew in red, well, the y coordinate isn't changing, so it's still going to be a -1. The x coordinate, if you take 8 plus -2, that's 6, and then you cut it in half, that's 3. So the midpoint of those two coordinates I gave you is 3, -1. So now we know the h and the k values. We can also use that information to say what's the distance from our center to either of the endpoints. It doesn't matter which direction you go, because that long way across the ellipse is what we call a. So the distance from the center to the major axis endpoints is the length of a. From 3, -1 to 8, -1, since the y-coordinate doesn't change, you can just focus on the x's. From 3 to 8 is a length of 5. They've also given us the minor axis length. So don't forget from the formula, the minor axis length is actually 2 times b, because it's doing the diameter all the way across the shape. So for our example, we have 2 times b equals 8, which means b equals 4. Now we're actually ready to write our equation for this one because we know all of the 4 values, h, k, a, and b. One thing I'll point out from the ellipse equations again, if you look back at this, even though we often use the c value to find the focus, it's not actually used anywhere in the equation. So if you can find the other 4 values without solving for c, then don't waste your time going through that process. So we have everything we need to write our equation at this point. So I'm going to have x minus h squared plus y minus k squared, and it's always set equal to 1. Your equation is always set equal to 1, so now we just have to figure out which of the a and b values go under x or y. So we said this one is stretching more to the left and to the right, which means our bigger number, a, needs to go underneath the x's. X is what dictates left and right motion. So since a is 5, a squared is 25, and since b is 4, b squared is 16. So that would be our equation there. And again, if you switch some of the orders on those things, that's fine, but for entering assignments into my math lab, they seem to always put the x term first, whether the bigger number is underneath it or not. Okay, for this last example, you aren't going to see any of these on the My Math Lab assignment when we come back to class, but it is very likely that we'll have some of these on the test, so I want to make sure that we get to look at them quickly now. This is going to be similar to what we did with the circle and the parabola, where we're given an equation, we have no idea what shape it is, we want to try and use completing the square to set up what shape it is. So the first thing I'm going to do is I'm going to group together the x's, and I'm going to leave a space, and then I'm going to group together the y's, and I'm going to leave another space. I'm going to move that other number to the other side. Now, before I can use completing the square, I have to factor out the number in front of the squared terms. You can't have a number in front of the squares when you're using completing the square. Okay, and then you take half of the middle number and square it. So for the first, the x piece, half of that is -1, squared is +1, so I add that to the left. But don't forget, I'm actually distributing a 9 through everything in the parentheses there. So it's not just 1 that I'm adding to that side of the equation, I'm actually adding 9 times 1. And then for the second one, half of the middle number is 2, squared is 4. I'm not just adding 4 because of the parentheses. I'm actually adding 4 times 4. So I need to add 16 to the other side as well. So now this will factor down. It's always x and half of the middle number. And I'll do the same thing for the y's. It's always y and half of the middle number. And on the right-hand side, we can add together those numbers. 9 plus 16 is 25, plus 11 more is 36. So we're almost done. The last thing we really have to notice is the other side of the equation is always supposed to be set equal to 1. So since I have a 36 there, I'm going to divide everything by 36, which means now I have x minus 1 squared over 4, because I'm reducing the 9 over 36. And then I have y plus 2 squared over 9, because I'm reducing the 4 over 36. And then that equals 1. So now we've taken the original equation, which did not match any of our forms, and put it into the standard ellipse form. So we've proven that it's an ellipse since it matches that equation. So at this point, we can say the location of the center is positive 1, negative 2. You could find the locations of the major axis vertices. This ellipse is stretching more up and down, so it's going up 3 and down 3 from the center. And if they want the minor axis endpoints, it's going left 2 and right 2. So this is all going back to what we did in the previous lesson of just being able to identify the center in which direction the graph is stretching up, down, left, and right. So that's all for the lesson today. Thank you, and then I should see you guys back in class on Thursday.